Rigid metal conduit, often called RMC, is a type of electrical conduit used to protect and route electrical wiring. Finding a direct chart that lists the resistance of RMC specifically is challenging because resistance depends on several factors, including the material's resistivity, the conduit's length, temperature, and the specific alloy composition of the steel. However, data related to the material properties of steel, which indirectly helps in determining resistance, can be found in various standards and codes related to steel structures and welding. Several resources provide information on allowable stresses and material properties of steel, which are relevant to understanding the resistive properties of RMC. Firstly, the American Welding Society, or AWS, Dun.1 Structural Welding Code Steel contains tables outlining allowable working stresses for welded joints. Table 3.3 provides allowable working stresses for welded joints and tension. Table 3.4 covers allowable working stresses for welded joints and compression, and Table 3.5 details allowable working stresses for welded joints and shear. Secondly, the American Institute of Steel Construction, or AISC, Manual of Steel Construction, 14th edition, provides comprehensive data on steel properties. Chapter F focuses on allowable stresses. Table 4.1 lists allowable tensile stresses. Table 4.2 details allowable compressive stresses. Table 4.3 provides allowable shear stresses. Thirdly, the Canadian Standard Association, or CSA, ESC design of steel structures includes tables relevant to stress limits. Table 5.1 outlines allowable stresses for welded joints and tension. Table 5.2 covers allowable stresses for welded joints and compression. Table 5.3 details allowable stresses for welded joints in shear. Fourthly, the European Committee for Standardization, or CEN, EN 1993-1-8 Design of Steel Structures Part 1-8 Design of Joints offers information on joint design. Table 6.1 provides the design resistance of welded joints to tensile forces. Table 6.2 covers the design resistance of welded joints to compressive forces. Table 6.3 details the design resistance of welded joints to shear forces. Fifthly, the International Institute of Welding, or AU, DOC, IIW 1539 Guidance on Quality Levels for Imperfections in Welded Joints offers guidance on quality. Table C1 details allowable stress ranges for welded joints and fatigue. These codes primarily deal with the structural integrity and strength of steel, particularly in welded joints, rather than the specific electrical resistance of RMC. However, they provide essential material property data that can be used to estimate resistance indirectly. To accurately determine the resistance of RMC, the following steps can be considered. Firstly, obtain the specific material composition of the RMC from the manufacturer. RMC is typically made of steel, but the exact alloy composition affects its resistivity. Secondly, find the resistivity value for the specific steel alloy used in the RMC. Resistivity is a material property that indicates how strongly the material opposes the flow of electric current. This value is typically expressed in ohm meters or micro-ohm centimeters. Thirdly, measure the length and cross-sectional area of the RMC section. The length should be in meters and the area in square meters if using ohm meters for resistivity, or length in centimeters and area in square centimeters if using micro-ohm centimeters for resistivity. Fourthly, calculate the resistance using the formula resistance equals resistivity times length divided by area. Ensure that the units are consistent. For example, if resistivity is in ohm meters, length must be in meters, and area must be in square meters. Remember that temperature affects the resistivity of steel, so the temperature during measurement or operation should be considered. Higher temperatures generally increase resistance. Because RMC is used in electrical installations, it's important to consider relevant electrical codes and standards such as the National Electrical Code, or NEC. The NEC provides guidelines for the proper installation and grounding of RMC to ensure electrical safety. However, the NEC does not provide specific resistance values for RMC. It focuses on ensuring that the conduit is properly grounded to provide a low impedance path for fault currents. In summary, while direct charts for the resistance of RMC are not readily available, understanding the material properties of steel, consulting relevant welding and steel construction codes, and performing calculations using the material's resistivity, length, and cross-sectional area can provide a reasonable estimate of its resistance.